In this video, we are going to look at the topic relative velocity. But before we actually jump into the topic, let us discuss a few things. Like in your junior classes, you must have heard about the concept of rest and motion being relative. That is, there cannot be something called absolute rest or absolute motion. You must be very familiar with this. Like, say, for example, two friends A and B are inside a moving train which is moving at a speed of 80 kilometers per hour. Now, when A looks at B, A will see B at rest. Likewise, B will see A at rest. But with respect to some other person C who's standing, on a platform, say, for example. So with respect to C, both A and B are moving. So therefore, a body which is at rest with respect to one observer at that very instant could be in motion with respect to some other observer. This is what is meant by rest and motion are relative. We cannot have absolute rest or absolute motion. Now we can go on discussing so many examples about rest and motion being relative, which of course we are not going to do in this video. But do remember, from this very idea of rest and motion being relative comes the concept of relative velocity. Now again, before we look at its definition, let us first look at a couple of everyday life examples or experiences which will help you understand relative velocity in a better way. Like, say, for example, you're moving in a car and the car is this. Okay, this is the only kind of car I managed to find for you all. Okay, so this is the car you are in, and this is another eraser car, say, for example. Now these two cars are moving in opposite direction. They are approaching each other like this. So you're inside this car and you're observing from this car. Now when they just happen to cross each other, you must have experienced that it seems like these two cars or this car to you seems like it just zooms by like this. Zoom. It moves very fast. Okay, the moment they are crossing, it seems to you that these two cars are passing each other with a greater velocity. They just zoom past each other. Alright, now this happens because of relative velocity. To give you another example, say for example it's raining. Now, neglecting any wind movement, a person standing will see raindrops falling vertically downwards like this. But to a person, say for example you're inside a car and your car is moving in this direction. So you're in this car, what you will see is, you will see raindrops for you coming at an angle like this. So this raindrop will be, you'll see raindrops coming towards you like this, inclined at some angle. And what it's like is, the faster the speed of your vehicle, the faster your car moves, the more inclined your raindrops will be. But for this person, the raindrops are still coming vertically downwards, remember. It is only for you moving in a car with a certain speed, raindrops are coming at an angle. If you're riding a bike, you will actually feel raindrops coming and hitting your face. And not just that, the faster the speed of your bike, the more raindrops will come and hit your face. The slower the speed of your bike, the lesser raindrops will come and hit your face. I don't know whether you've experienced this or not, but this is actually what happens. And all this happens because of the topic of the day, relative velocity. So finally, how do we define it? The velocity of a body as seen by another body is called the relative velocity of the first body with respect to the second. To explain it in even more simple words, say you move in a car towards the north and the car is moving with velocity VA, and your friend moves in another car towards the east and the velocity of the car is VB. So to this man, stationary man, so when this man looks at you, he will see you moving towards the north with a velocity VA. this man looks at your friend, he will now see your friend moving towards the east with a velocity vb. But when you look at your friend now, the thing is, you will not see your friend moving towards the east, and the velocity of your friend will also be something different other than vb. Likewise, when your friend looks at you, your friend will see you moving in a different direction other than north, and of course with some other velocity. This is what relative velocity deals with. Like in the case of the raindrops falling, a stationary man was seeing the raindrops falling vertically downwards, but you moving in a car, for you the scenario is completely different. So the velocity of a body, velocity meaning both its magnitude and direction, don't forget, the velocity of a body as seen by another body is what is called your relative velocity. Mathematically, how do we calculate it? If we have a body A moving with velocity VA and we have another body B moving with velocity VB, then the relative velocity of A with respect to B meaning B is the observer over here. A body B which is moving with velocity VB is looking at body A which itself is moving with velocity VA. So what does it look like? What does the motion of A look like to body B? That is what is called relative velocity of A with respect to B, and it's given by VAB. The velocity of A as seen by B is equal to VA minus VB, which can also be written as VA plus of minus VB, because addition and subtraction are one and the same thing.